So today I want to start with the introduction to trigonometry. Alright, so trigonometry plays a huge role in math, plays a huge role in what goes on outside the world. Remember, we talked about bridges use trigonometry, building bridges uses trigonometry. Um, Leveling instruments, when you see those surveyors on the side of the road, they have to use trig in order to get what they need. Remember, music uses trig. So there's a lot of things that have to do with trig. It is the study of triangles, and it's the relationship between the sides and the angles of right triangles. So we've been talking about right triangles, sides and angles of right triangles. So it's pretty important. We've been talking about right triangles and special right triangles. That was the 45, 45, 90 and the 30, 60, 90. So these are the types of triangles that have different angles that aren't specifically the special right triangles. And you'll be able to use trig to solve them. Okay? So when we start out, you have to know what sides are what. So you have to know opposite, adjacent, and hypotenuse. So if I'm looking at, remember, you never use the 90 degrees as one of the angles that you're trying to solve for. You're always going to use one of the two acute angles. Okay, so you know that 90 degrees is your right angle, so that means the other two angles have to add up to 90 degrees. Well, they're called complementary angles. Complementary angles. And when you talk about complementary angles, if you're looking at one of them, if I'm looking at theta, I have sine of theta. I know that the other angle, let's just call it A. I know that the other angle, I can do cosine of A, and those two things will equal each other when you put them into the calculator. So when I say sine of theta, if I give theta a number, if I said that this was 60, I don't want you guys to think I'm talking about 30, 60, 90, so let me change that to 61. So if I said this angle was 61, that means that this angle up here is 29. So complementary angles would be that sine of 61 is equal to cosine of 29. And you could do it the other way around. I could have cosine of 61 be equal to sine of 29. If you don't believe me, just put it in your calculator. Those are called complementary angles. There'll be questions on your test about complementary angles. So depending on which angle you use, if you use sine of A, then you're going to use cosine of whatever that angle is in the opposite corner. Okay, those are called complementary angles. Now let's talk about naming our sides. So here's my first triangle. I'm going to do both angles, and I'm going to go by theta. And I've told you, depending on what they tell you, which angle, they will always tell you an angle. You need to know which is adjacent, what is opposite, and what is your hypotenuse. So I'll just go ahead and name these. We don't want to put that one as B. It's normally C. So I'll put C and B. So I want to know always across from my 90-degree angles is my hypotenuse, no matter what. It doesn't change. It's always the hypotenuse. Okay, so the most important thing is you have to remember what adjacent and opposite is. So the side or the number like the B that is closest to that angle that you're looking for, and right now I'm looking at this angle right here to make that my reference point. The closest number to that corner is your adjacent side. So between A and B, the closest one is B. This would be your adjacent side. So then that forces all the way over here to be your opposite side. Now you can think of it another way. Adjacent means it will always be a part of this angle, the line that makes up part of this angle. The other line is always the hypotenuse. So the two lines that make up that angle, the one side is going to be the adjacent and the other side is going to be the hypotenuse. The line that never touches your angle is always the opposite. Now this changes if you're looking at your other acute angle. So if I'm now looking at this angle, my adjacent, the closest side, would be this. Over here would be the A. And my opposite would be my B. So this is something really important that you're going to have to really realize what's going on. And of course, always across from your 90 degrees is your hypotenuse. Okay, so that's the first thing you better figure out pretty quick. Which side is adjacent and which side is opposite. Okay, so then we can go on to talking about the functions that work for trig. And you have three of them. You have sine, and sine equals some old hippie, opposite. Oh, I can't even spell it right now. Opposite. A-O-P-P-O-S-I-T-E. Those of you in class know I'm a terrible speller. Over a hypotenuse. And then you have cosine. So comes around, that would be adjacent here. Comes around here. So that's hypotenuse. And then you have tangent. Comes around here, tripping on, so that's opposite over apples, adjacent. So those are my three trig functions that I have to use when I'm talking about trig. And what I've told them in class is some old hippie comes around here tripping on apples. Okay? So we're going to use those when we start to talk about our trig. All right, so we've labeled our triangles, and we want to go into, I guess the first thing we need to go into is maybe a simple ratio problem. So if I have a triangle and they give me all the sides, so this side is 13, this is 25, and this is 36, and they're telling me to look at, question is, here's your triangle, the question is going to be something like, give me the cosine of B. What's the ratio? To cosine of B. How about to sine of B? And to tan of B. So for one corner, you can find three ratios. So if I do cosine, look up here, we've got adjacent over hypotenuse. And I'm talking about this angle right here. So I have to make sure that I'm talking about the right thing. So cosine of B is adjacent over hypotenuse. So my adjacent side, which one is closer, the 13 or the 25 to B? Of course, the 13 is. So 13 is going to be my adjacent over my hypotenuse. Okay, and you're going to reduce these if on the test, if they can be reduced, you reduce them. All right, so sine of B is opposite over hypotenuse. All right, we've already decided that this is my adjacent, and this is always my hypotenuse. So that forces this 25 to be your opposite. It's farthest away from the angle. So I have, let's see, we're doing sine. So I have opposite over hypotenuse. So that would be 25 over 36. My opposite side over my hypotenuse. Tangent, sorry about that, let me plug in the computer before it dies. There we go. So my tangent is going to be opposite over adjacent. So opposite is 25 and adjacent is 13. So depending on what the question actually asks, if it tells you to reduce, simplify these answers, then you have to simplify them. If you have to turn them into a decimal, then you just take 13, divide by 36, and put it in your calculator and turn it into a decimal. So these are the easiest. This is just setting up the ratio. That's all that is. So you have to memorize the sine, cosine, and tangent, and you have to be able to label your triangle. It's the most important part. All right, so let's go on to yesterday in our homework. We had to do these ratios. So that was that part. We also had to, let's see, I'm looking at your homework. We had to label the ratios. Looks fairly simple. I could do one of the problems off your homework. And I don't know, how about tan of A? And this is problem 14 on your homework. So as I'm looking at it, it's labeled C, B, A, 29, 21, and 20. What did I say? 14 on your homework. Okay. So when oops, we need a right angle, don't we? There we go. So when I'm looking at this, they want tangent of A. So I told you guys to circle the corner that you're actually looking for. So, and you can always right off the bat tell me where the hypotenuse is, and that is this one. So what is the ratio to tan of A? Opposite over adjacent. So I need opposite over adjacent. So I need to figure out which one of this, 21 or 20, which one's closer. The 20 is closer, so it is adjacent, and this would be, 21 would be opposite. So you have 21 over 20. That would be your answer. So just, part of that homework was fairly simple. You just had to list the ratios, okay? So then now one of the more important concept is how to find a missing side. So when we talk about missing sides, you're given usually two sides and an angle, and you have to decide. So I'm going to do number 4 off your other homework sheet, and they give you that this angle is 25, and they give you that this is 90, and they give you 10, and they give you x, and you're told to find the missing side. That's that x. Okay? So you're only going to be given one angle. Well, you're actually given two. You're given the 90 and the 25. You never use the 90 to solve these problems. Never. So what I'm going to use is this 25 degrees right here. I need to base my positions off that 25, off that angle. Okay? So when I look at, I need to figure out what did they give me? What pieces of information related to that angle can I use to solve sine, cosine, or tangent? Because I've got to solve this to find that x, to find that missing piece. All right, so when I look at angle 25 degrees, this 10 sits closer than that x, so this 10 is my adjacent. And then across from 25, well, we know this side is always a hypotenuse, so that's good. So then if I have two of them, I can force myself to know that this is the opposite, all right? So then I have to think which one of the trig functions uses opposite and adjacent, and you'll always only have one of them that works. So as I look up here, I can see across the board that tangent is the one that works. So you're going to use tan of 25 degrees because we're solving these now. And I need opposite over adjacent. So I need x over 10. Now I didn't solve for x. That means x has to be by itself. So x divided by 10, the opposite of division is multiplication. So I have to multiply both sides by 10. That now gives me my x by itself. And I can take my answer that I've got, 10 times tan of 25, and put it in your calculator and get an answer. And I do not have a calculator with me. We talked about how to put that in your calculator. Is nothing more than hitting the 10 times the tan button and 25, and that'll give you an answer. All right, then you need to think about that answer. So Hold on just a second. Let me get a calculator. Sorry about that. So if I have tan, I got 10, tan, 25. So that means it's we're going to say 4.7. So I need to look at my triangle and decide if that 4.7 kind of makes sense. And remember, I didn't draw to scale. So it's smaller than my 10. We don't know our hypotenuse. So it kind of makes sense. If I was given how could I find my hypotenuse? Ah, Pythagorean theorem. So if I have both my legs, I've got 10 squared plus 4.7 squared equals my hypotenuse. So I can actually find my hypotenuse if I wanted to. So that's 100 plus 4.7 squared is 22.09. When I add those together, I get 122.09. And then I can square root both sides, and when I square root 122.09, I get 11.05. So that's my C. So if this is my C, if this is my hypotenuse, both of my numbers are smaller, which makes this good because they both have to be smaller than your hypotenuse. Your pretty good answer choice there. Okay? So that's finding the missing side. That's only one way to find a missing side. There's another way. When your x is in the denominator. Notice in this problem my x was in the numerator. So I need to have a problem that solves where the x is in the denominator. So let's just switch these two pieces of information. I'll make up a new, we're going to put x over here, and we'll put, say, 15 over there. So still with my angle of 25, and I still want to find my missing side. So x is my adjacent now, and 15 is my opposite. So I have to set it up. So opposite and adjacent is still tan. So I still have tan of 25 is equal to my opposite, which is 15, over my adjacent. So now my x is in my denominator. I got to do two things. And that's all it is. One more step than the last one. So I still have to, those two are divided. The opposite of division is multiplication. So I still have to multiply by x to get that off the bottom. So now I have x times tan of 25 is equal to 15. All right, is x by itself? No. Now they're being multiplied, so the opposite of multiplication is division, and I still need x by itself. So I have to divide by tan of 25. And I put that in my calculator, and that's going to give me x. So I put in 15, hit the divide button, hit tan, type in 25, and you get an answer of 32.17. So now my x is 32.17. So I could check my hypotenuse again if I needed to. Sometimes, let's see. All right, we'll do it. I was trying to debate whether to actually check for my hypotenuse. So 15 squared plus, and I'm going to drop the 17, so I'm just going to say 32 squared is equal to c squared. So 15 squared is 225 plus 32 squared is 1024. If I add those two together, 225 plus 1024, I get 1249. And then I have to square root both sides. So when I square root 1249, I get 35.34. So looks good. This is 32. That number looked large, but if my hypotenuse is 35.34, I'm good to go as long as this number is smaller. So that is how you find the missing side. Good luck! And don't forget that you can always text me or send me a picture of the problem you're having trouble with, and I can help you that way. Thanks!